Hey y'all, so we're looking at domain and range today, and this is something it's really important you get familiar with because we're going to talk about it in every chapter in Algebra 2. It's just such an important concept for us. And hopefully you remember from algebra that domain is talking about the x values and range is talking about the y values, and I think we know to associate domain with x and range with y, but sometimes it's hard to figure out what does it actually mean? Like what we get the domain is x's, but what do I do with that? What does that tell me? So before we dive into that, I just want to kind of talk about some uh, symbolic stuff. And if we have a closed dot, that means that a value is included. It means I can actually equal that point. When I use an open dot on the graph, like I do in this graph right here, right, that left endpoint is open, that's going to mean that that value is excluded, meaning I can get really, really, really close to that point, but my line is never actually going to equal that value. And then when I do interval notation, I'm going to use parentheses when there's an open dot, or infinity, it's when I can't actually equal that value, and I'm going to use these square brackets when the endpoints are included, when a value can actually equal that. Okay, so we'll kind of jump into that as we need to use it, but let's circle back to what does domain and range actually even mean? So we know that domain are the x values, and the question is, what x values could this line equal, or does this line equal? And in order to answer that, we need to understand that a line, a solid line like this, is made up of an infinite number of points. So I'm going to go ahead and just emphasize a couple here. Okay, you get the idea. These are all points that lie on that line. And we could calculate exactly what these are. I'm just going to make good guesses. I'm just going to get kind of close. My answers are not going to be perfect. We'll talk about how would I calculate these in chapter 1. But for now, we're just talking about domain and range. Okay, so it almost looks like this point right here goes through negative 5, 5, right? That means I go 5 to the left on the x-axis, 1, 2, 3, 4, 5, and then I go up 5 on the y-axis, 1, 2, 3, 4, 5, negative 5, 5. Okay, again, that's not actually what this point equals, it's just close enough for us to understand what domain means. Okay, I'm going to do the same thing for the next point. Okay, this point right here looks like it's at negative 4, comma, up 1, 2, 3, maybe that's like 4.25, 4.25. Again, I'm just guessing. These are not actually correct, or they're not perfect. They're close. Okay, my next point, negative 3, and that almost looks like I go up 3.5. I'm going to kind of skip around now. Like this looks like I go left to right 0, so 0, comma, then up 1 maybe. And let's do one more. Let's do like this point right here is 2, and then I go down, let's just call that a half, make it easy. Okay. So when I ask what's the domain of this, it's asking what is every single x value that I could possibly write down as one of these points. I can see I have negative 5, I have negative 4, I have negative 3, I have a 0, I have a 2. But that's not all of them. There's some points that I haven't listed yet, and I didn't do even any decimals for the x's. I could have done halfway on some of the x's, and like this point right here, that would be negative 3.54. ish. Right, so there are a bunch. There's an infinite number of x values, but I know for sure all of the x values are always going to be in between -6 and +4. Because if I look over here at like x equals 7 on that x-axis there, for 7, there's just absolutely no x value anywhere that I could list an ordered pair for x is 7. So x definitely can't equal 7. It can't equal 6. It can't equal 5. It can't equal 4.5. But it could equal 4, right? There is a point right here. And this is where that notation comes in handy. Looking back at -6, I can't actually equal -6 because that's an open dot, but I can get really, really close. If I zoomed way in on this graph, there would be a point that is like -5.999, comma, and it looks like I'm getting really, really close to 1, 2, 3, 4, 5, 6 up, so maybe 5.999 in the y. So I could equal -5.99999 or 5.9999999. I just can't actually equal -6. Okay, so that helps me answer some of these questions over here on the left. So we need to state whether -6 is included, and x equals -6 is not included. So we can go ahead and say that's excluded. We just talked about that. But 4 had a closed dot, so 4 is included. And so that helps me answer the question of what is the domain. The domain of this graph is going to be, I can pick any number starting from -6 and going up all the way to +4. And what we call this is interval notation. Let's see, I'll have room over here. This is interval notation. So again, because it says domain, I know I'm talking about the x's, and this interval tells me I could pick anything on my graph from -6 out to +4, and there will be an x value, or there will be a point that has an x value between those two numbers. Okay, I'm going to go ahead and erase most of this work because it's the same idea for range. Okay, so for range, we hopefully remember it's associated with the y values. And so I want to ask, what are all the y values now? So I see a y value of 5, a y value of 4.25, a y value of 3.5, 1, -0.5. I can see that I'm going to get y values all the way in between -2 all the way up to, this is +6. And there's absolutely no points down here. I'm not going to get anything that's less than -2, and I'm not going to get anything that's bigger than +6, but I do have values for everything in between those. So then the next question we just need to ask ourselves, we know the interval is from -2 to 6, but are those end points included? And at -2, we can see that -2 is closed in, so I can actually equal -2. But up at 6, that has that open dot, so that's excluded. So -2 is included. And 6 is excluded. Okay, which means I'm going to use a square bracket for -2 on my range and a parentheses for 6. Okay, so this is in interval notation. That's what the directions told me to do. But sometimes you will see domain and range written in set notation. And I do like set notation because set notation makes it so that way you don't actually have to write down the whole word domain. So we can write down x such that x is in between 0 and 4. And we use those inequalities where this first inequality says that I cannot equal -6, but the second inequality says I can equal 4, right? So it's very similar to the difference in parentheses. And sometimes there is more to set notation. Sometimes you will see x can be any real number, so bringing back that notation that we talked about earlier, such that x is in between 6 and -4. Oh, sorry, -6 and +4. And sometimes just like a lazy set notation is you can just do that inequality. And a lot of times on ACT they will just give you just the inequality part, which is perfectly fine. But if you just do the inequality, you need to make sure that you're using the correct variable in between, right? Domain is always x. And for range, let's do it that lazy way, which is okay some of the time. That range is going to be between -2 and +6, and making sure you use those correct inequalities there. Okay, so that's what we're talking about when we discuss domain and range. So some helpful hints for thinking about that as you look at a graph. I like to imagine that I'm walking along the graph. So for domain, domain is x's, we walk along the x-axis, and we're looking specifically, using this graph as an example, I like to start on the left, and you always want to start on the smaller side, so the negative numbers are the smaller side. We're going to walk this way, and there's nothing, right? There's no points anywhere here. But as soon as I get to this spot right here, I start seeing the graph. It's an open dot, but I do start seeing the graph at -6. And then I keep walking along, I still see graph, I still see graph, I still see graph, and then this is the last time I'll be able to see the graph, because if I keep walking this way, I'm not going to see anything else on the graph there. Okay, it's the same idea for range. We just want to start at the bottom when we're doing range. Start at the bottom and work our way up. Do we see anything? Nope, 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 nope. Now I do, right? So that's the important part. We're going to start here at -2. I chopped off my head. Okay, so we start at -2 and we keep climbing. I see function, I see function, I see function, I see function, right? So I keep climbing up and up and up and up and up, and this is the last time I see that graph on the y-axis. So that goes all the way up to 6, and that helps me to find my range. Okay, hopefully you kind of have an understanding of what domain and range is. You can go ahead and pause the video, try example 2 on your own, and check your answers with me. So domain, I'm going to start over here. And this is the first time I see the graph. That's at -1, -2, -3, -4, -5, -6, -7. It's a closed dot, so -7, comma. And then 1, 2, 3, 4, +5 is going to be the last time I see it. That is an open dot, so it gets a parentheses. Okay, for range, I'm asking what are all those possible y values? Well, I start at the bottom, always start at the bottom, always start on the negative side. We're going to go up, and again, I don't see anything, I don't see anything, I don't see anything. This is where the graph starts for those y values. So this starts at -1, -2, -3, and it's going to go up to, this is the last time I see that function 1. So -3 has a closed dot, 1 has an open dot. There we go. Okay, B. Domain. We're going to start over here. Walk this way, nothing, nothing, nothing. Okay, here's the first time I see the graph. There's no dot there though, right? This is just a completely solid line. Oh, I didn't trace that very well. But what we need to remember is that a line is made up of an infinite number of dots. That's what makes it a solid line, is it's a bunch of dots all lined up to make a continuous line there. So even though there is no dot there, we know it's acting like a closed dot because it's a solid line. I know I zoomed in and it kind of looked like it wasn't, but it's supposed to be. So solid dot right there. So it definitely starts at 0 with a bracket. And then there's arrows on the end of this function. So if I were to zoom out on the graph, this would keep going this way forever, and it's going to keep going this way forever. So it's actually going to go up to negative infinity. I could have any positive x value, and as long as I could zoom out far enough, it would still be there on the graph. And since we can't actually equal infinity, we're going to use a parentheses for that. Okay, range, same idea. I start at the bottom. And even though right here I can't see anything, right? There's no graph down here at the bottom. Oh, I raised my little dude. If I climbed up and up and up and up, and like this is really the first time that I see it. This is at -1, -2, -3. If I were to zoom out on this graph, we have to be really careful when we see arrows. Because if I were to zoom out on this graph, like this, for example, this is all the way down at like -4 or -5. And if I were to zoom out farther, it would keep slowly going down forever. So the range, if I could zoom out far enough, actually does go both down forever and up forever. Very slowly, but it does. So that's going to be negative infinity to positive infinity. Okay, C. Domain, I'm going to start on the left, walk, 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 walk. This is the first time I see the function, -1, -2 at -3. 1, 2, 3. I stop seeing the function at 4. They are both open circles, so -3 to 4. And my y values start at the bottom and climb up. I don't see any function, no function, no function, no function, no function. Okay, this is the first time I see it at 0, and it's a closed dot, so 0, and then up to 1, 2, 3, 4, 5 is the last time I see it. Those are both open dots, so it's going to get a parentheses. Sometimes you end up in an interesting situation where one of the dots is closed, but one of the dots is open. And even though I can't actually equal 5 over here for the y value, right? So I could equal like -2.999, 4.999. I could get really, really, really close to -3.5. For this right side, it does exactly equal 4, 5. So since there is at least one point where the y value is 5, the y would be included there. That's obviously not the case for this graph, but I just want to let you know if you do see that, it is possible. Okay, and this guy. Okay, start over here. Starts here, which is at -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, 6. They are both closed dots, so they're going to get 2 square brackets. Okay, the y's start at 0, and they stop at 1, 2, 3, 4, 5, 6. They're all closed dots, so 0, 6. On to the back. Okay, we've already talked about most of the information up top, so let's just hop into some more examples, which again, I highly encourage you. Pause the video, make mistakes, learn from your mistakes. I already know how to do all of this, so I would encourage you, check your answers, and if you get it wrong, then listen to me just yapping away. Okay, domain. It looks like it starts here, right? It looks like it starts at -7, but there's this arrow on the end. So I have to imagine it keep going this way which will keep going to the left forever. So it starts at negative infinity. And same deal over here. This arrow is going to mean it keeps going this way forever, so it's going to go to positive infinity. And spoiler alert, most of the functions that we look at this year are going to have domains of negative infinity to positive infinity. Not all of them, but a really good chunk of them. Okay, range, we're doing top to bottom, so it does go down forever and it goes up forever, so that's also negative infinity to infinity. Okay, this is an interesting graph where it's kind of like split up into two chunks. We still use the same rules we've been using. And just so you know, this is called a piecewise graph, and we will look at that at the end of chapter 1 some more. But for now, we just have to be able to say the domain and range. So looking for my x values, this is definitely going to go to the left forever, so negative infinity. And we need to be careful with this break as I keep walking. Okay, the graph stops right here at -2, and then it starts again at -1 on the x-axis. So there is a little break where like I will never have an x value that equals -1.5. So we have to represent that in our interval. So negative infinity all the way until -2. It is a closed dot, so it's going to get a bracket. And there is a second interval that starts at -1, and then it does go to the right forever. So it's going to go up to infinity. And that -1 gets it gets a parentheses because it's an open circle. Okay, range. Careful with that gap again, but let's just see. We go up and up and up, and this is where I start seeing the function. That's at -3. It's a closed dot. And as I go up, it does kind of like the graph is in two places now, but I still have every single y value going up this way. And I have some double y values, but that's okay. There's not any that I skip or miss. So it does go up forever. So I only have to write one interval for the range because there's no break in the values of y. Okay, C. Domain, start on the left, and it is slowly going to the left and the right forever, right? It's very slow over here, but eventually if I were to zoom out far enough, it'd be probably like way up here, but the graph would eventually get there. Okay, so that's going to be negative infinity to positive infinity. Range. We start, right here at -6. And remember that solid lines count, or they act like closed dots. Okay, something that's important for us to recognize is repeating patterns on functions. So a lot of times I'll see students who say, okay, well on problem C, this arrow meant it goes up forever. And this arrow means this goes up forever. Okay, well, it probably means the same thing here. This goes up forever and this side's going to go down forever. And while that is sometimes the case, like it may be the case on a graph that looks like, I'm going to draw this off to the side, a graph that goes up and down a little bit. That one does go up and down forever, but let's look at the difference between what I drew and the graph that we're given in D. So what I drew, even though it does squiggle up and down, the height of the squiggles changes, right? So it's not perfectly the same every single time. And so I can tell that there's not really a pattern. It's a little bit more sporadic. So that's how I know that the ends are just going to go up and down forever. Okay, that's different from the graph that I was given in D because look, every single wave is exactly the same height and exactly the same depth. And so if you notice that that is definitely a pattern, this arrow just means that that pattern goes on forever. So you just have to be careful at how you interpret those arrows. Is there a pattern, or is it a little more sporadic, and so it does actually go up and down forever like other problems we've done? Okay, so if we assume this pattern repeats forever, then the domain, it goes left and right forever, negative infinity to infinity. But then the range, like I said earlier, it only bounces between those two values. It's everything in between -2 and +2, but it never goes above or below that. So -2 to +2. So just be careful and look out for those repeating patterns. That's something that you're going to have to decide for yourself. Okay, E. Again, I have some squiggles, but they're sporadic. It's not bouncing between the two same numbers. So this does mean that's going to go down and right forever. This one's going to go up and left forever. So it does go left and right forever. And it does go up and down forever. Okay, domain. We go off to the left forever, so negative infinity. But this is another piecewise where we have that break in the graph. So we need to be careful from -5 to +1. So we're going to have a split domain again. So -5 has an open dot and 1, 2, but it does go to the right forever, so positive infinity. Okay, you may see either online or with a tutor or something, sometimes instead of the word and, people will put this union symbol. That technically is not correct. You're not supposed to do that in interval notation, but I'm never going to take off points for that. I just want you to know there's a reason why I don't do it. But if that's something that you see, if that's someone that someone's taught you, you can keep doing that. It really doesn't matter until you're like in a college level math class where they're going to start taking off points for that. Okay, range. We start at the bottom. It goes down forever, so negative infinity. And we need to be careful with this jump again. So I keep going up and up and up and up and up and up. And this is where this one ends. And it's closed in. And then even though this is an open dot, I can get really close to -3 from over here. So even though the graph is separated, there's actually no break in the y values. I can be every single y value from negative infinity to positive infinity because it does go up forever. Ooh, 3 sections of a piecewise. So it goes to the left forever. Actually, I'm going to move this up so we have room. Negative infinity to -7. That's an open dot. And then I go from -5 to 2. And then I go from 5 to infinity, right? Hopefully you're tracking with those 3 different chunks. Okay, I'm going to do the same thing for the y values. It goes down forever, so I have negative infinity to 0, and then there is a break. Look, there's a whole chunk of y values missing in that, in this interval right here. So negative infinity to 0, that's an open dot. And then the graph starts again at 1 and it goes up to 3, but there's a break again. And then I go from 4 up to infinity forever. So this one we actually did have 3 separate intervals for domain and 3 separate intervals for range. Ooh, a discrete function. So this is something we'll define tomorrow actually, but when we have individual points like this, we call it discrete. And I can't write this in interval notation really because I can't be any x values for domain. I can't be any x values between -7 and -5. I can only be exactly -7 or exactly -5. Okay, so we want to write these kind of as a set. We're going to use this brace. It's kind of like fancy, pointy, squiggly parentheses. And we're just going to list all the x values from least to greatest. So we have -7, -5, -2, 0, and 5. And again, I was getting these numbers just by going along the x-axis and finding every single dot that's on there. Okay, I'll do the same thing for the y values. I'll start at the bottom and just list every single one that I see. So I see -3, -2, so let's start listing those. -3, -2, 2, and then I have 2 of them up here at 4, but I only have to list it once because it's just telling me all the possible y values, and one of the possible y values is 4, and I see it twice, but we just have to list it the one time. Okay, and I really want to challenge you on example 4. Pause the video here and try this yourself. There are so many different graphs. You can do a piecewise graph. You can do just like a curve. You can do an absolute value. But there are so many different graphs that you can draw to satisfy a domain from -infinity to +infinity and a range from -5 to +infinity. So it needs to go left and right forever, and it needs to go from -5 up forever. So I'm going to draw 2. I hope yours looks different than mine though. So maybe I'm going to draw like a V shape for this one. So a V that goes down to -5, but then it can't go past that. So it goes up forever, left and right forever, but it stops at -5 for the range. Okay, for this one I'm going to be a little more fun. This one I'm going to draw a piecewise function. So maybe I'm going to just draw a line. So I know it has to equal because it has this bracket right there. So close dot. I'm just going to draw a line on this side. But then maybe I'm going to start over here and do an open dot and go up like this. Ooh, but wait a second. That works for the range, but there's a chunk missing for my domain. So I have to be all numbers, right? Because my domain's supposed to be -infinity to +infinity. So I just need to fill that in somehow. Maybe I will draw another. This will be a 3-part piecewise. Maybe I'll do from like here, and then maybe I'll connect it down. Maybe I'll make it like absolute value. There we go. Now my domain is all real numbers, and my range just goes from -5 to infinity. So that's kind of turned out weird looking, but it has the correct domain and range.